Let's start by understanding the core principles of Arduino using an example. Let's say we have a smart car that is equipped with automated headlights. This car checks the light intensity of the environment and turns on at night and turns off during the day. So what sort of equipment would be required to build such a system? We would need a headlight to output the lights and a light sensor to give us information of the ambient light. Now there has to be something in between that gets the input from the light sensor and outputs the signal to the headlight. This something is the brain of the system. We call it the microcontroller unit. In short, MCU. MCU is like a small computer that can handle small amounts of information really fast. So where does the Arduino come in? Arduino is a company that produces microcontroller boards. They have different versions that cater different scenarios. The most commonly used is the Arduino Uno. They also have more compact versions like Arduino Mini and bigger versions that can handle more sensors like the Arduino Mega. The main difference is the size, capacity, and number of pins between these boards. Uno has 14 digital and 6 analog pins. Mega has 54 digital and 16 analog pins. This means we can connect 20 different sensors and devices to Arduino Uno and 70 to the Arduino Mega. Note that the Arduino does not produce microcontrollers. They produce microcontroller boards that contain microcontrollers. So what's so special about these Arduino boards? Even though when referred to Arduino, the hardware comes to mind, but the speciality of the Arduino is in its software. It makes the process of programming much easier than any other similar device out there. In earlier times, we used to write tons of lines of code just to turn on an LED. But now with Arduino, we can achieve the same result in just 3 simple lines of code. So we can say it is a high-level language that takes care of the coding details for us so that we can focus more on the actual project. So how does the Arduino work? As mentioned, Arduino has its own software through which we can program different sensors and devices, and we can upload it to the Arduino board. We can use a regular USB connection to upload the code using a computer. Once the code is uploaded, it keeps running as long as it keeps getting the power. So let's have a closer look at the most commonly used Arduino, the Arduino Uno. The main component is the MCU that handles all the logic. Then we have the USB connection to upload the program to the board. We also have a power jack that allows external battery to be connected to make it portable. The reset button resets the code without deleting it. Then we have the pins where we attach our components. We have 14 digital pins, 6 analog pins, and we also have power pins with 5 volts and ground. So what do these digital and analog pin mean? Digital signal has only 2 states, which means it can be on or off, whereas analog signal has a range of states. Let's look at an example of a fan. If we control the fan digitally, we have the option of turning it on and turning it off, where on would mean 1 and off would mean 0. If we control the fan with analog signal, this would mean we have a range of values. Therefore, we can now control the speed of the fan rather than just on and off. For example, the range is from 0 to 255. 0 would mean off, 255 would mean full speed, whereas 127 would mean half the speed. But where did this 255 value come from? Well, this is an 8-bit value, which means we have 256 values. Bit values are used all around us. For example, when you buy a smartphone, you have the option of buying a 64 GB, 128, 256, 512 or even 1 terabyte hard disk phone. So where do all these random values come from? These values are binary values, where 64 is basically 2 to the power of 6, 128 is 2 to the power of 7, 256 is 2 to the power of 8, 512 is 2 to the power of 9, and 1024 is 2 to the power of 10. This means if we were to send a 6-bit signal to our fan, we would have 64 different speeds to control. If it was an 8-bit value, we will have 256 speeds to control. If we include the 0 as well, then our values will range from 0 to 255. Coming back to our automated headlight example, we have an analog input in the form of the light sensor and analog output in the form of a light. Now this time we will use the Arduino controller to run the system. For analog input, Arduino uses a 10-bit value, and for analog output, it uses an 8-bit value. So this means for our light sensor, we get a range of values from 0 to 1023. So 0 would mean dark, and 1023 would mean fully bright. Similarly, based on the light intensity we received from the light sensor, we can output a value to the headlight to turn it on accordingly. For the 8-bit value, we have the range of 0 to 255. So we will have 256 brightness values. Let's have a look at some examples of input and output devices. A distance sensor would be an analog input. A push button would be a digital input. Motor would be analog output, whereas LED light would be a digital output. The distance sensor is an analog input because it gives us a value of distance, for example in centimeters, rather than just saying the object is near or far. The push button is a digital input because it has only two states. It can either be pressed or not pressed. The motor is an analog output since it can be controlled with varying speed. The LED light is a digital output because it can be controlled to be either on or off. Note that the motor and LED can be used both as digital outputs as well, since they both can be simply turned on or off. So, to summarize, Arduino is a company that produces microcontrollers, which we can use to control multiple sensors and devices. These devices could be inputs or outputs of the system, and we can have two different types of signals that we can send or receive from these devices. Now, these signals can be digital or analog. Digital signals have two states, whereas analog signal has a range of states. For analog input, the Arduino uses a 10-bit value, which ranges from 0 to 1023, and for analog output, it uses an 8-bit value, which ranges from 0 to 255. In this video, we have just scratched the surface of the Arduino microcontroller, as there is tons of information related to Arduino. To truly understand it, we have to get our hands dirty by experimenting and inventing new projects. The possibilities are endless. We can even build our own custom Arduino boards and use them to create our own projects.